part of the series of lectures that I'm doing on the different type of pumps that are used in the oil field, in the oil and gas industry. These pumps have been specifically designed over the years and have been tailor-made for the oil and gas industry because of the challenges that are faced by the oil and gas companies. So today I'm going to talk about the sucker rod pumping systems. Sucker rod pumping systems are one of the most numerous types of pumps that do you use to see in the oil field, in the oil patch. It is one of the icons of the oil patch. Whenever we talk about the oil and gas industry, we always see this pump jack. We call it a pump jack. Some people call it a nodding donkey. It is called in the industry by different names, but the more proper, more technical name is a pump jack. This pump jack is part of an entire system of artificial lift pumping, which is called a sucker rod pumping system. We are going to talk a bit more in the coming slides about what this system is made of. But uh, one of the things which I want to mention on the introductory slide is that SRP, or a sucker rod pumping system, is one of the most commonly used artificial lift system in the world, and it accounts for 70% of artificial lift on the planet. That's why you see it as being an icon on of the oil and gas industry. It is used in different emblems. It is used in different type of marketing material. It is very, very abundantly to be seen in the oil patch. And over the period of years, although it's not a new innovation, it's not something which is new in the market. It has been around for almost a century. The industry has advented into different type of materials, different type of designs, in which we have optimized the geometry of the pump jack, and we have optimized the production that comes out of the sucker rod pumping systems. And it is highly customizable. It can be used from 5 barrels of production per day to 5,000 barrels of production per day. So it is highly customizable, very flexible, and it can be used in different type of environments. So there are 3 basic components or basic subsystems of a sucker rod pumping system. The surface pumping unit, which you see right over here, this is called a pump jack, also called a surface pumping unit. This is followed by a sucker rod string, which are these 25-foot rods that are called sucker rod strings. They connect the top surface pumping unit to a downhole pump, and they are actually made up to each other, and they make an entire spring. And then in the end, at the very bottom of the well, we have a subsurface reciprocating pump. There are numerous advantages of sucker rod pumping system. That is why it's so widely used in the industry. It's very well known. People are very familiar with it. Operators that operate these oil and gas industry or oil and gas fields across the globe, they are very, very familiar with it. There is not a lot of training that is required in the operation of the SRP system. We can easily manipulate the production rate by changing the strokes of the sucker rod pumping system. We can either change the stroke length, we can reduce it, increase it, or we can increase the number of strokes per minute, or SPM, and we can increase our production or decrease our production. It is very flexible, all the way from 5 barrels per day to 5,000 barrels per day. And we can actually reduce the pump intake pressure to almost 0. And when we reduce the pump intake pressure so that there is absolutely no obstruction for oil and gas to come into the pump, we can actually maximize our production. It can be automated with the help of the on-site controllers, rod pumping controllers, and we can operate it in a way that nobody has to go on the sucker rod pumping system for months. It can be connected through a SCADA system, so it can be viewed remotely, and it can be controlled remotely, and we can actually create computer generated dyna cards or dynamometer cards, which can be used to optimize production from these wells. One of the things about the sucker rod pumping system is it's so flexible and so movable that the equipment has a very high resale value. That's why if the well is abandoned, the well is not producing anymore, the sucker rod pumping unit on that well is actually taken off, removed, and moved to a different well. and then you can actually continue production on a different well. You don't have to scrap the equipment. It is not This equipment is not designed for well to well. It is very, very customizable. It is very, very universal, so you can actually deploy it on a different well. So one of the things about the sucker rod pumping system is that it is good for medium to shallow depths. That means as you start going deep and deep, your production will start declining. That means the sucker rod pumping system is not good for offshore wells. It's not very good for deep water wells. That's why in the offshore applications, in subsea applications, in deep water applications where you see those uh, FPSOs or jackup rigs, you actually don't see the sucker rod pumps. The reason for that is they are not very good for very deep applications. And this is a graph that is just depicting that it is the production is optimized between 1,000 feet to 4,000 feet. And you can see that as you go towards 5,000 feet and 6,000 feet, the production declines incrementally. Um, and as you go deeper than that, there is absolutely no production at all. The reason for that is that the sucker rod string is just too big or too long, and we do not have a pumping unit that is sized for that kind of depths. Um, so that is one of the limitations of the sucker rod pumping system. Now, what are the applications of sucker rod pumping systems? As I mentioned earlier, it can be used for very low flow application as well as medium flow applications with the pump setting depth of 100 feet to 10,000 feet. However, we try not to go above 5,000 feet just because the production declines drastically, and we have better methods of artificial lifting when we go to 10,000 feet applications or deeper than that. It can be used for deviated wells as well as horizontal wells. But when we go to deviated and horizontal wells, we have certain design considerations that we will discuss later on. But primarily, we have to use rod strings with guides on them because otherwise the rod string will rub on the tubing that is downhole. It is used for moderate to low sand cut, less than 10%. The reason for that is higher sand cut result in abrasion, and the pump will get damaged. It is used for low to medium GOR ratios. That means it is used for low wells that are producing low gas or medium gas. But if it's a very gassy well, then we try to avoid this method of artificial lift, and we try to use gas lift systems. It is also used for steam-assisted gravity drainage applications, in coal bed methane applications, dewatering of the gas wells, as well as then the heavy and light oil applications. So it is very universal in that regard. A sucker rod pump system is actually consists of, when we talk about the downhole pump, it's a very simplistic construction. Uh, it is actually made of three components. Uh, One of them is pump barrel. Pump barrel houses the different type of valves. Then there is the bottom valve is called a standing valve, and the top valve is called a traveling valve. Essentially, what happens is that I have an animation which shows that how the pump operates during an upstroke and a downstroke. Essentially, what happens is that in the upstroke, the standing valve will open and it will let the fluid pass through it and go into the pump barrel, while the traveling valve will remain closed. While in the downstroke, the standing valve will close, so there is no fluid going past this valve, but the traveling valve will open and it will let the fluid go past it and through the tubing onto the surface. This is just a small animation that shows how does it work. So your standing valve will open, let the fluid pass through it, and in the downstroke, your traveling valve will open and let the fluid pass through it. So very simplistic construction, not a lot uh, of moving components except the traveling valves and the standing valves, and as well as the rod string which is going up and down. So there are different type of sucker rod pumping systems. There is a API code that governs the construction of the sucker rod pumping systems. Um, these are some of the pictures around the globe. There is a picture from Middle East, and then there's a picture from North America. And at the bottom, you can see the plant that actually manufactures the sucker rod pumping system. There are numerous plants around the world that are very strategically located around the areas which use these sucker rod pumping systems. And these plants manufacture these SRP systems using API code. So the manufacturing as well as operation is very strictly controlled to meet certain specifications. These are some of the basic components of a sucker rod pumping system or a pump jack out on the surface. Starting with right over here, you have your prime mover. Right over here, this prime mover could be electric motor or a gas engine. Then we have a gear reducer, which will reduce the high RPMs of the prime mover to the RPMs which are more suitable for the pumping unit. Then there is a brake linkages, brake assembly. The brake assembly is primarily to stop the pumping unit. You have your bell covers, cranks, and then as we go towards the top, we have the pitman arms over here. The pitman arms actually connect the gear reducer with the walking beam. This is what we call a walking beam. Then there is a horse head. It is called a horse head because it kind of resembles a horse head. And then over here we have our carrier bar, and then over here we have our polish rod, and this polish rod actually passes through a stuffing box as well as the wellhead, and then it goes downhole right over here. As I mentioned earlier, that the unit nomenclature and the unit is actually the manufacturing as well as specification of the unit is determined by the API code. This API code is one which determines different type of gearbox ratings, structural ratings, as well as the stroke lengths. This is just a schematic or a side view of a balanced beam, what we call a balanced beam pumping unit. It is manufactured to the API standard, so it delivers a very high reliability, a very quiet operations. One of the advantages of the sucker rod pumping systems is that it's highly reliable. You can set it and forget it. It does not require a lot of maintenance, just a periodic maintenance to check the oil in the gearboxes, and just few quick checks on the stuffing box is all what you need to keep this unit operating for years and years. That's why it's so numerously common sight in the oil and gas industry. These units have very high saddle bearings, self-centered drive bearings. So that's why the industry has moved to a point where the selection of material is so top-notch that it delivers a very high reliability. One of the things that is coming in the industry, and it has been around for almost 2 decades now, but it is not as old of a technology, is what we call a hydraulic pumping units. In this lecture, I'm not going to dive deep into it because it's an entire topic of its own. But one of the things that have come up and they have gained a lot of popularity now is that compared to a pump jack, these hydraulic pumping units, although in principle operate in the same way downhole, but on the surface, they look way different from a normal pump jack. And the thing, one of the advantages of the hydraulic pumping units is that it uses hydraulic oil to pump oil and gas from the well, and they do not take as much of a space as a conventional pump jack. They can deliver same performance, they can deliver same amount of flow rate, they can deliver same amount of production, and you do not have a lot of surface facilities. All you need is a hydraulic pump jack right over here, and then we have a power unit which is right beside the hydraulic pump jack. So it has a much reduced footprint. It can be installed much more quicker, and it can be run with a very long stroke, so it improves the production. And it can be delivered in either with electric or a gas power skid with different type of horsepower ranges available. So it is very modular in that aspect. Wellhead pumping assembly. So essentially, you have seen the sucker rod pumping unit, you have seen the downhole pump. One of the things that we do talk about is the wellhead pumping assembly, because the wellhead pumping assembly of a SRP system is different from a conventional well. At the very top, we have a polish rod. This polish rod has a very high surface finish, and it connects the pump jack or the surface pumping unit with the sucker rod string. The polish rod clamp is at the top, and then we have what we call a rod rotator. Essentially, by using a rod rotator, you can actually rotate the entire string. At the bottom of that rod rotator, we have what we call a stuffing box. This stuffing box has a rope packing in it. Essentially, it seals around the surface of this polish rod, and it makes sure that the oil and gas that is coming from the bottom of the well does not get exposed to the environment. Then the second most important component is what we call a pumping T. It is called a pumping T because essentially your oil and gas will flow through this tubing into the tubing head, through the BOP and into the pumping T. At the pumping T, what happens is that the flow of the oil and gas changes its direction. It will go take a 90-degree turn and it will go through this flow line out into your battery and or into your separator. One of the things which you see right below the pumping T is what we call a blowout preventer. This is not the blowout preventer which you usually see on the drilling rigs. It's a much more smaller thing with the smaller rams. And it acts as like a sealing device, a secondary containment device. And what we do is that whenever we are doing any maintenance, we can actually close this clamp or these rams and fill seal around the stuffing box. For example, if you have to change the stuffing box packing, what you will do is that you will turn these rams so that it will close, and now you have a secondary containment and you can change or work on your stuffing box. One of the things which I talked about over here is the polish rod clamp and a polish rod. This is the polish rod. This is called a polish rod because it has a very high surface finish. And essentially it connects your sucker rod pump or sucker rod pumping unit at the top of the well with the sucker rod string. So polish rod has different type of specifications. What you see right over here is the most basic specifications, which is 1045 piston steel. And as you go towards the higher specifications, what happens is that you can actually get, for example, for XM19, you can get a very high tensile strength and a yield strength, along with high percentage elongation. This is used more for deviated wells, deep wells, or wells with high H2S, just because it has a better metallurgy. While in case of a sweet well or well where there's not a lot of H2S, we can actually use 1045 piston steel. The more common which I've seen in oil and gas industry up in North America is the 4140 alloy. It's right in the middle. It is very, very for the applications that are used in the North America, 4140 alloy just serves the purpose very well. As I mentioned earlier, that the polish rod attaches to a sucker rod string. The sucker rod is essentially a 25-foot long rod. There are some other rods which are called pony rods or smaller rods which have different lengths. They can be a 2-foot, it can be a 6-foot, it can be a 4-foot rod. But essentially sucker rod is made up of 24 or 25-foot long rods. These are rods connect from the top and they are made with each other. So it goes all the way to the downhole pump and it connects the plunger of the pump. One of the things, these rods come in a bundle, and they are all actually manufactured to a API specification, and they all come in a standard length. Essentially, these are transported in a bundle to a well site, and then they are made up with each other through a coupling, and that's how they are deployed downhole. Sucker rod metallurgy also depends upon your well condition. There are certain wells where there's not a lot of paraffins. They are not very deep, so your rod loads are not that high. So you can actually settle with a 4142M or DA type grade, and you can see the different type of material specifications or the composition of materials for those. Essentially, as you start going towards the right hand side of this table, you will see the HS grades and KD grades. These are used for more aggressive applications, deeper applications, because as you can see over here, the yield strength of this material actually goes, for example, in this case, it's 60 KSI, but as you go towards HS grade, it's 115 KSI. And similarly, your tensile strength also starts increasing as you go towards a higher grade. So one of the things about the higher grades is that they can be used in the deep applications, longer wells, deeper wells, deviated wells. You can actually use a higher grade of metallurgy. The sucker rod strings also come in different diameters. One of the more common diameters is 3¼ that is very commonly used in the sucker rod pumps. But as you go towards a higher diameter, you can actually improve your rod load, so you can actually set your pump deeper in the well. But the more common sizes is 3/4 and 7/8. As you go towards a higher grade, for example, or a higher diameter, for example, 1 inch or 1 and 1/8, that is more used for PCP applications or rotating pump applications rather than sucker rod pump applications. One of the things about in the industry is that they usually come in 1 and 1/8 increments, and usually 1 inch, 7/8, and 3/4 inch sucker rods are referred as 86 string, and 7/8 and 3/4 is usually referred to as 76 string. As I mentioned earlier, that these rods are connected through couplings. These couplings play a very important role in makeup of the rod string. And selection of a coupling can actually make and break your string design. Usually there are two types of couplings. One is called a slim hole coupling, and it is called slim hole coupling because the OD of that coupling, or the outer diameter of that coupling, actually matches with the outer diameter of the rod makeup point, or the makeup connection. And then there's the second type of coupling, which is called a full size coupling. And you can see that the OD of the coupling is bigger than the OD of the rod. Now, there are different design considerations when we are selecting either of the couplings. Slim hole couplings is primarily used when you don't have very high rod loads, because it has lesser metal, so the strength of the coupling is slightly lower as well. It is used when you have very tight tubing restrictions, because the bigger the coupling is, the lesser the flow that is going to go past it, and it can actually pose a flow restriction. So you select a slim hole coupling when you have a smaller tubing, you have restrictions in your flow, so you try to use a slim hole coupling. But when you have a bigger tubing and you don't have a lot of restriction on the flow, then we use what we call a FST, or a full size T coupling. One of the things about the sucker rod string is that although it can be bare or plain as this one, so you don't see any rod guides on these, and that is perfectly fine. In some of the well designs, you don't need a rod guide. But if you have a deviated well or a deeper well, then you need what we call rod guides installed. These rod guides are actually installed on the outer diameter of the sucker rod string. They actually serve different purposes. Some of these rod guides reduce the tubing wear, so they actually act like a centralizers, and they will reduce any rubbing of the rod string with the tubing. That is one of the primary reasons. They can actually also be used for what we call removal of paraffins. So when we are pumping oil and gas, the presence of paraffin in the well is a very real possibility. These paraffins stick on the wall of the tubing, and what they do is that they actually pose flow restrictions. So they can be actually used as a scraper for that as well. So as the rod string moves up and down, these scrapers or these rod guides will actually remove paraffins, and then they can flow all the way to the top. Different manufacturers have different type of designs, different type of selling points, selling features. Primarily, they are made up of polymer, which can be a PPA, PEEK, or PPS. The selection of polymer as well as selection of design depends upon your well trajectory, your well design, the presence of different type of chemicals downhole, as well as if there is any production of H2S or CO2 from the well. And that will determine what kind of polymer you will use uh, for your rod guides. For the sucker rod pumps, there are different types of sucker rod pumps. The more common ones are called either insert pump, tubing pumps, or oversized pumps. We are going to talk about what the difference is between all three of them. But when we talk about the downhole pump, these are the three types of pumps: insert pump, tubing pump, and oversized pump. Um, the insert pump is called an insert pump because essentially you don't need to do any modifications on the tubing. This pump can actually land on a special type of profile downhole in the tubing, and then you can start pumping. So even if your well was not designed with a sucker rod pumping system in the mind, you don't have to change a lot of things. Uh, you can actually use an insert pump, and then you can start production using a sucker rod pumping system. Now, for the tubing pump and the oversized pump, you have to keep this in mind when you are designing the well. That means at the time of completion, so you know that the well will go through drilling phase. It has to go through hydraulic fracturing. It will go through the hydraulic fracturing, and then there is a completion phase. In the completions phase, you will deploy your tubing, and then you will decide what type of artificial lift system you will be going to use. Either it is going to be a sucker rod pumping system, a progressive cavity pumping system, electrical submersible pumping system, gas lift system, or a jet pump. Now, the problem about, or one of the limitations about the tubing pump and the oversized pump is that if you are going to use either of these pumps, you have to take this into account at the time of completion. Otherwise, you will have to change a lot of things at the surface or downhole. That means you might have to pull the tubing, or if you are going to use a tubing deployed pump or an oversized pump, then you have to have different type of accessories and profiles in the tubing itself to make sure that they are deployable. The specification or the nomenclature of the API pump is usually determined by API. So whether you will buy it from manufacturer A or manufacturer B, the subsurface pump designation is very, very common. That means they will follow a certain nomenclature. In this nomenclature, first two digits are usually your tubing size. That means which tubing it will be deployed into. And then your nominal pump bore size, so your pump barrel size. And then what type of a pump is it? Is it an insert pump or if it is a tubing pump? And then the next designation is your type of a barrel. Is it a heavy barrel? Is it a slim barrel? Is it a thin wall barrel? Is it an extra heavy wall barrel? And things like that. And then the next designation is type of your seating assembly location, and then your seating assembly type. And then next designations are primarily based on what is your barrel length, your plunger length, your upper extension and lower extension lengths. So one thing which I want to kind of emphasize over here is that the API code makes sure that your pump nomenclature is standardized, regardless of whoever the manufacturer is. Talking about the downhole pump, the first thing which I'm going to talk about is what we call an insert pump. As I mentioned earlier, insert pump is called an insert pump because you can deploy it later in the life of the well as well. You don't need special preparations. All you need to do is deploy this pump as part of the rod string. The rod string will go inside the tubing, and this pump can actually sit inside the tubing and start pumping. There are different types of pumps. RW are usually thin wall barrel pumps, RX is medium wall, and RH is heavy wall pumps. Essentially, you can actually change the thickness of the barrel over here. And then what will happen is that with the increased thickness, although your flow rate will not change, or the flow rate might change, but we do that. Why we select different type of barrels is because of the sand production. A thin wall barrel pump will actually erode with the introduction of sand. That part comes as a part of the oil and gas, and it will wear down the barrel of the pump. So if you, in the well testing phase, if there is a lot of sand in in the well, then you don't want to go with a thin wall barrel pump. You would rather go for a medium or a heavy wall barrel pump. Uh, One of the things about the insert pump is that the complete pump is attached to and inserted into the well tubing string with the help of the socket rod string. That means you do not need this pump is not attached to the tubing at all. It is part of the socket rod string. So that makes it very flexible. You can pull it. Pulling a rod string is much easier than pulling a tubing string. So you can actually pull your rod string and you can actually change the pump if it goes down. Sorry about that. The next type of pump is called what we call a tubing type pump. Now, the difference about the insert pump and the tubing type pump is the tubing type pump, as the name indicates, the component of this pump is actually sitting with the tubing itself. It is made up with the tubing. That means changing this pump is not that easy. If you have to change the part of the pump that is attached with the tubing, then you have to pull the entire tubing. But one of the advantages about the tubing type pump is that since it is a bigger pump, it has a much bigger internal diameter or the flow area. That means you can actually optimize your production. That means you can have a higher production through this pump. And the name of the game is production. The production is directly proportional to the revenue that oil company will generate. So in the well economics, it's very important to determine what type of pump you are selecting, because that will determine the revenue that you will generate out of that well. So the tubing bore pump actually gives you a larger bore size. And these pumps are actually, they are quite heavy walled, so they can actually tolerate a much higher sand production through the well as well. And the heavy wall barrel with the extensions and pump PSN is a pump seating nipples actually runs on a tubing string, while the plunger and the standing valve is installed with the sucker rod string. So the barrel of the pump and the pump seating nipple are part of the tubing, while the standing valve and the plunger are part of this rod string. So there are some components of this pump that you can actually replace by just pulling the rod string, but not all the components. And then one of the things about this flexibility that the TH pump or a tubing type pump will offer you is that for high production wells, it is very suitable, and it is very suitable for the shallow to the medium depths. And as I mentioned earlier, the tubing string needs to be pulled if you are going to replace the barrel. But if you are just changing the standing valve or the plunger, you don't need to pull the tubing. And one of the limitations of the tubing type pump is just because it's too long. For the wells that are producing a lot of gas, because of the distance between the valves, just because there is a lot of distance between the valves, it can actually result in a gas log. So not recommended for high GOR wells. And the last pump in this series is what we call an oversized tubing type pump. It is called oversized because it is much bigger. It can actually afford you a much higher flow rate and a much higher flow rate area. And it is very much made like that. But one of the things about this is that the standing valve and the plunger are also part of the tubing string. That means they are made as a part of the tubing string. And by doing so, we can actually have a much higher flow rate area. That means we can produce more oil and gas through this pump. While the sucker rods are run into the well in a very conventional manner and attached to a pump by the help of our on and off tool. So the sucker rods will come and attach at the top of this plunger. And then there will be an on and off tool that can actually remove or disconnect the sucker rod string. But in this type of pump, both the pump barrel, standing valve, and the plunger are part of the tubing. Now, all of these, the barrel of the pump, the plunger of the pump, the valves, the fittings, all these come in a different type of metallurgies. These metallurgies are very much dependent on what type of fluid you are producing. If there is a H2S in the well, if there is CO2 in the well, and based on that, you can actually change your metallurgy and make sure that your well design is optimized for the production that you are going to get. Automation and optimization, as we are descending into the era where the remote monitoring, optimization, well site controllers are becoming more and more common. Similarly, for sucker rod pump systems, the technology is also advancing towards that arena as well. So we have these well site controllers with which can actually optimize based on your well production. It can optimize it can optimize in a way that it protects the gearbox and the downhole equipment. So if there is a gas interference, if there is a gas lock, if there is too much sand production, it will actually shut down the pump. It will send a signal to your SCADA system, through your SCADA system to the operator, and it will say that this well needs to be looked into because either there is a gas lock or a gas interference. It will not just run the pump dry and eventually it fails. It can actually generate different type of production profiles. It has different type of torque controls, rod load controls. It can store the data, it can trend the data, and it can transmit the data. One of the things when we talk about the sucker rod pump is what we call a dynamometer card. In the industry, this is more commonly called a dyna card, short form of a dynamometer card. Essentially, what you do is that you actually try to trend or plot your how your pump is performing. And this plot is based on load versus position. At the start of the upstroke, as I mentioned earlier, when the upstroke begins, the traveling valve closes. And as the upstroke is halfway, then the standing valve open and the full fluid load is actually transferred to the pump and the rod string. As you start moving towards the end of the upstroke, the pump moves up and the production fluid is lifted out of the tubing into the flow line. And then as you start going towards the downstroke, what happens at the start of the downstroke is that the standing valve closes. At the mid of the downstroke, the traveling valve opens and the fluid load is transferred to the tubing. And towards the end of the downstroke, what will happen is that the pump will move down and the production fluid will go through the traveling valve into the tubing. And then your upstroke will begin again, and then your fluid will be lifted all the way to the top. So dynamometer card is essentially your load versus position graph, and it gives you a lot of indications how your pump is performing. This is just a quick animation of how the dynamometer card is actually run. So it will track your upstroke, your downstrokes, and then again your upstroke, and halfway through your upstroke and towards your downstroke, towards the end of your downstroke, and it will tell you at what point your standing valve is opening, your traveling valve is opening, and it will also tell you other type of indications. For example, this will tell you the rod stretch, and all of it is being tracked. Either it can be made to a manual chart, or either it can be done through the controller. And this gives a lot of diagnostic or prognostic health monitoring information to your well site operator or to your engineers, and it can tell them that how your pump is performing and what needs to be done. As we go towards the end of the presentation, there are two types of challenges that are very predominant in the sucker rod pumping system. These are called gas lock or gas interference, and these are primarily done. These happen primarily when you have a lot of gas in the well, and when there is a lot of gas in the well, it can actually impediment or impede your production. So we are going to just take a quick look at both of these scenarios. So this is what we call a gas interference. So the gas will not let the fluid go past it, and it can actually let a decrease in your production. And this is what we call a gas lock. Essentially, nothing is getting lifted. This gas is actually preventing any fluid to go, because the gas is not very easily passable through the pump. So the gas will just stay inside the pump barrel, and it will not let any fluid to be produced to the surface. All right. I guess we have reached towards the end of the presentation. I have 20 minutes to take the questions.
Thank you very much, Prof. Syed Hassaan. Ladies and gentlemen, I hope you are fairly satisfied with the overall presentation by our subject matter expert in that field of mechanical engineering with a specific focus on the soccer rod pumping system. Professor Syed Hassaan provided what I would call a global overall description of the most popular or most commonly used pump system, the SRP. And I mean, in the world of oil and gas industry, of course, we were dealing with a lot of technical terms, some of which you might have trouble to understand. But this is exactly what the world of education is all about. We go to school because there are things that we don't know, we don't understand. And then when it happens in a setting of education, like with those live class sessions, we simply raise our hands and ask questions, which is exactly what Ike Edwin Nana is trying to achieve right at this time as we are moving to where Ike Edwin is for his question. Go ahead, brother.
Yes, good evening, everybody from Nigeria.
Good evening.
My question goes like this. In oil exploration, we know very well that all the environments where the oil will be located, they are not all of the same soil texture. And if that be the case, what decides the particular type of pump that will be used according to the soil texture of any particular area where we are going to drill the oil? The
Okay.
factor that determines the type of pump.
All right.
That's my question, sir.
Professor Hassaan.
Thank you. Very good question. So usually your soil texture will be, it's not very important when you are selecting your method of pumping. When you are selecting your method of pumping, one of the few things that you will consider or that actually affects the design of the artificial lift system is that what type of fluid you are lifting. Is it a medium oil? Is it a heavy oil? Or if it's a light oil? That actually depends. Your GOR ratio, your gas to oil ratio, how much of that is it? Is it a very high GOR well or gas to oil ratio well? Because if it's a very high GOR well, that means it's a very gassy well. So you have to take that into consideration. The next thing is your water cut. How much water do you have in your production fluid? Very high water means that your economics will change towards a certain type of artificial lift methods. Then, for example, if there is a very high water cut well, then you try to use artificial lift system, which is most economical, which is most cheapest to operate. For example, a sucker rod pump system is very cheap to operate. All you need is electricity on site. You need some surface preparation, and and that's it. But if there is a well in which there's a high production, less GOR, you need it is the water cut is like it's almost zero. Then you need something which is more premium. For example, you would need a ESP pump system because now you can actually produce more oil and gas. So to go back to your question, the soil texture may have some uh, effect on your drilling conditions, but not on your artificial lift conditions. Your artificial lift conditions are based primarily on your type of fluid you are lifting, the well geometry that the artificial lift system needs to go through, and that's it.
All right. I hope our participant is fairly happy with the answer provided by Professor Hassaan. As we are now moving to Stelio Sambane. Stelio Sambane, I'm sure you have a question for us or our presenter, so the turn is yours right at this time.
Okay, good afternoon.
Good afternoon.
Everyone, okay. Yes, my question is regarding about the three types of the pumps. I saw that we have the inserting, tubing, and oversizing. So I would like to know the comparison between them about the prices.
Good question.
Okay.
So
Yeah.
in terms of pricing, the insert pump is the most cheapest one, and the oversized pump is usually the most expensive one. The reason for that is the oversized pump will actually have a bigger geometry, more material, more machining involved. So it is usually considered a premium, while the insert pump is usually smaller geometry. It is it's not very difficult to deploy. So that is usually considered the most cheapest in it amongst the three pumps.
Okay. Before we go to the next participant with a hand up, we're gonna travel real quick to our channel, our chat box. And there is a segment of your presentation, Professor Syed Hassaan, that dealt with the presence of gas. Gas that is interfering with the process or gas that is blocking the process. You mentioned both gas interference and gas lock. My understanding is the question from Dr. Sidney Ben is in the same line of thought. And this is what Dr. Sidney asked. How is the gas removed without removing the entire pump?
Very good question. So if there is a presence of gas or if there is a high GOR ratio, we try to design our system with a gas separator. So the gas separator can be attached to the entrance of the pump. And what will happen is that gas separator can get rid of some of the gas. Now, if there is a gas lock in the pump, there are few things that we can try as part of our diagnostics as well. We can actually change our SPM, which is stroke per minute, or we can actually change our stroke length, and we can see if it will get rid of that gas lock.
That's
If not, then we may have to go for a well intervention.
Okay. Very, very clear, Dr. Sidney. I hope you got the answer you were looking for. At this time, we are moving to Jim Musa. Jim, the floor is yours at this time.
Good evening.
Good evening. Go ahead.
My question, I want to know the difference between insert and tubing, and also the disadvantage and advantage.
I'm not sure whether you heard that, Professor Hassaan. Okay.
Yes, I did. So I will go to that slide. So the difference between the insert pump and the tubing pump is that insert pump is not part of the tubing. That means you can actually attach it with the rod string and deploy it in the well, and it will just sit inside the tubing, and that's it. So while the tubing pump is the part of the pump which you see over here. So one of the things one main differences which you will see between the insert pump and the tubing pump is that insert pump has these seals in it. So it will sit inside the tubing and it will seal around this tubing, around these seals, and then it can pump through it. Now, in the tubing pump, this stationary assembly is actually part of the tubing. And then this traveling assembly is part of your rod string. Now, what you see right over here, one of the main big differences which you will see right over here is that the tubing pump is bigger. while the insert pump is smaller and more cylinder. So what will happen is that the tubing pump can actually pump more oil through it, while the insert pump cannot pump that much oil through it. Just because it's smaller, it has a flow restriction. While in case of a tubing pump, it has a thorough bore over here, so it does not have that same restriction.
Impressive. Reminding you, ladies and gentlemen, that you are with Atlantic International University, and this is part of our series of live class sessions, an initiative that you do not find elsewhere. This is our, let's say, our characteristic at Atlantic International University. Thank each and every one of you for your attendance. And at this time, we have a question from Olufemi, Oluleye, Olufemi. Are you using an SRP? Go ahead for your question, Olufemi.
Thank you very much, sir.
You're very welcome.
Thank you, Professor Syed Hassaan, for a beautiful and excellent presentation. Please, sir, my question is centered on the deviated or horizontal well. Are we going to expect the same performance from the Tucker Road pumps in deviated or horizontal wells, same as for vertical beds? So that's number one. Then secondly, I don't know if you can also give us some design considerations or design criteria for the pump set depth for deviated or horizontal wells. That's second question. Then the third question.
Let's look at the first and the second question. Actually, it should be no more than one question, as we have some other participants with hands up. Thank you for your understanding, Olufemi. And now going back to Professor Hassaan for an answer.
Okay, so in the horizontal or the deviated well compared to a vertical well, there can be a performance difference. They cannot be. Depends upon how well you have designed your string. The design considerations for the deviated and the horizontal wells is that your rod string will go straight or it will have to go deviated. So you have to use your rod centralizers. So your rod remains centralized to your bore of the tubing. And that is very important, just because if you won't do that, if you don't put the rod centralizers or the rod guides on it, what will happen is that the tube will be eroded over the period of time, because your rod will actually sit on the tubing and it will result in a phenomena which is called hit or hole in the tubing. That means over the period of time, the rod string will keep on rubbing with the tubing. It will take the material away, and eventually it will come to a point where there is a hole in the tubing. So that is very important. So one of the considerations that is one of the primary considerations in the deviated and the horizontal wells compared to a vertical well is that you have to use your rod centralizers. Regarding the design considerations for the pump setting depth, every production engineer will tell you that he wants to set the pump as deep as possible. Because if you will try to set it as close to your pay zone, that is where you will optimize your production. So that is the primary consideration.
Ismail, today is not an exception. He is here again to ask a question to our subject matter expert, Professor Syed Hassaan. Go ahead, Ismail. Ismail, are you there?
Yeah, I'm here, sir.
Okay, go ahead.
Yeah, the audio was malfunctioning. Yeah. Good morning, sir.
Hello.
Yeah.
Yes.
Good morning, the presenter, and good morning, everyone. Yeah. My question is this: what maintenance practices are recommended for sucker rod pumps to maximize their lifespan, and how can the artificial lift technology, including sucker rod pumps, improve oil recovery rates in mature wells?
Thank you.
Thank you, Ismail.
Yeah.
Very good question. Coming back to your first question, actually, I will address the second question first. So the artificial lift technology is very important when it comes to mature wells, because the mature wells, as you might know, they cannot, the reservoir pressure is not enough to push the fluid all the way to the surface. When that is the case, you need artificial lift system. A lot of wells onshore or on the land right now have come to a point, or coming to a point, where they are mature enough that the production is depleted to a point where there is not sufficient reservoir pressure. So all the production engineers are usually always thinking about our artificial lift system all the way from the onset of the well. So even if it is not mature, they're still thinking about artificial lift system, because the selection of artificial lift system, especially at the completions phase of the well, is very important to maximize production. Otherwise, you won't be able to maximize production. Otherwise, you will have to work with rerounds. So they are working on making sure that there is enough pad completion, there is enough pad preparation. If they need to pull the certain type of power with the voltage, the amperages and hertz, they are making sure that that power is available on the website from the very start of the well.
Wonderful. Let's go back to the chat box now with a question from Dr. Jane Chuku. How can we actively stop or supervise the rate of influence in adjusting pump or manipulation of pumping machines for effective work practice? Question from Dr. Jane Chuku, if you get that, Professor Ali.
So the two things which can actually result in a very quick manipulation of the pump is adjusting your strokes per minute, SPM, as well as your stroke length. So this is something which can be done on a well site controller. So the controller which I showed you right over here, this can actually change. Although there are simplistic controllers as well, this is probably a high-end one. So it can actually help you to control the SPM and the rod length and the stroke length, and it can actually manipulate your production. One of the questions that was asked earlier was about the maintenance. So going back to that question about the maintenance of the sucker rod pump, usually there's not a lot of maintenance that is required. All you have to do is probably on the surface unit, we might have to just check the oil condition, as well as change of the oil filter after a certain number of hours on your primary fluid, prime mover, if your prime mover is a gas engine. But if it's an electrical motor, all you have to do is probably grease on the grease ports that are on the two sides of the electrical motor, and so that's it. Or probably you might have to check the condition of the belt that is running between the prime mover and the gearbox or gear reducer, and that's it.
All right. Reaching the end of the timeline granted by Professor Syed Hassaan for questions, but we do have a hand up. With the permission of Professor Hassaan, we're gonna allow Abdoulaye Sis to ask the last question for this session. Ladies and gentlemen, let's listen to Abdoulaye Sis.
Hello, Mr. Valsin. How are you?
Just fine. Thank you for asking.
Thank you very much. The course was very wonderful, and we understand everything related to the course lift But here, my question is that, how to manipulate lift and how many meters the lift took place. It is going over the oil or it is just near to the oil? What's happened about it? Thank you.
Thank you very much.
Thank you. So how to manipulate the lift? Again, same thing. Either you can change your stroke length, or either you can change your strokes per minute. That means if you start, if you will actually ramp up your RPMs of your prime mover, you can actually increase the strokes per minute of the pump. And by actually changing your stroke length, you can actually go for a low stroke or a high stroke, and that can actually change your lift lengths as well. And then similarly for a lift length, usually